have like sort of we evaluate our own thoughts, like, oh, we think whether our thoughts make sense or not. Then if not, we will backtrack, think, okay, the solution doesn't make sense, and then we will try to explore different thoughts. So this kind of capability, which is to reevaluate our own thoughts and then to backtrack and search new thoughts, is not naturally embedded in LLMs, because as we talked before, that LLMs is like reads token and then it will generate the tokens after it. So the idea of thoughts is that we want to deliberate this kind of human process when we deliberately evaluate our thoughts, and then if it doesn't make sense, then we stop. We're not going to explore the source anymore, and we will search different ways which makes more sense. So that's roughly the general idea and the inspiration why this algorithm was developed. Yeah, so here in the paper they say in humans we have this two kind of systems of thinking: a fast automatic conscious mode, which is the normal will do, but human also have this slow deliberate conscious mode when we different thoughts, different alternatives, and then evaluate it. So system 2 is the thing that is introduced in this tree of thoughts algorithm. And besides that, definitely, because when we when the LLM realized that its thought doesn't make sense, then it needs to search for a better, more meaningful thoughts. It's also materials like search space. Like that's why I introduce here that we need to implement a searching algorithm, and because here represents and the intermediate thoughts we can use the classic BFS breadth for search or BFS depth for search to traverse tree and see like which of three makes the best answer or the best possible thoughts. Yeah. So here they compare this with the
Inneke, sorry, we lost the presentation.
To do prompting.
Hello, Inneke?
All this input output prompting, we just provide and expect the LLMs to come up with the answers directly. The second way,
hello, Inneke,
is called thoughts.
Oh no. Yeah, I think you're having internet problems, Inneke. Can you hear me? Slightly.
Hello.
Maybe turn off your video.
Can you hear me now?
Yes, but I think your internet is slow. You may want to turn off the internet. They're cutting off. Turn off the video. Sorry. And we lost the presentation.
I think now we left her. I lost her.
Oh no. Yeah, maybe she's rejoining.
Yeah.
Hello.
Inneke?
Okay.
Yes, your internet is lagging. You want to
Okay.
start sharing?
I'm turning my video. Oh, hopefully that helps.
Yeah, but please share the screen. Or should I share it? Do you want me to share it?
I'm sharing it now. Let's try again.
Yeah.
Hopefully
Yeah.
it's better now with my video. I'm sorry, guys.
Yep.
Uh,
You should change your internet provider, maybe. It's better now.
okay.
That's fine now.
Where were we? I think we're talking about this different kinds of simpler prompting.
Mm-hmm.
Yeah, the simplest one is the input output or IO prompting, which is as easy as we give the input and expect LLMs to come up with the answer directly without any intermediate steps. The next one is called chain of thought prompting, which was like the prompt technique that people used before this tree of thoughts was introduced. The idea is that we want the LLMs to have intermediate thoughts instead of directly jumping to the final results. But the difference with tree of thoughts is that in chain of thoughts, it doesn't have the capability to evaluate its own thoughts and to backtrack and search for other thoughts. So I think this diagram here explains this better. So for the IO prompting is just directly input and output. For the chain of thoughts, we have this intermediate thoughts, but we are not able to re-evaluate this. And for this self-consistency, with chain of thoughts is just basically the extension of thoughts where we do ensembles. So we will do voting on each intermediate thoughts, and we pick the most voted one as the output. So with tree of thoughts here, we represent the thoughts as like it has intermediate thoughts, just like chain of thoughts, but then we can start first to the tree and then go back if it's not good. And like, for example, in this case, the green ones are considered as good thoughts. So we will follow the green ones, and if at some point we reach red, okay, forget about it. We'll backtrack and we will find the good ones. Yeah, where is it? Okay. So in this tree of thoughts, there are 4 steps, 4 general steps, and these 4 steps are modular. That's the selling point, they say, because we can customize each of these 4 steps depending on what problems you want to solve, without like being coupled with the other stages. So what are those 4 steps? First one is it's called the thought decomposition. So basically it's the formulation of the initial thoughts. And the thing that we want to consider in this thought decomposition is that we want the thoughts not to be very small, so that it like really like restrict the problems, but we don't want it to be too large so that it's very fake, and yeah, it's like it has a lot of ambiguity. So that for example here, in this evaluation later we will see that the example of thought decomposition is that, okay, we want to solve a game of 24, and then every line of thoughts is the equation, or we want to write a passage, and then the thoughts is this paragraph of the passage. The second step is called thought generator. It is the step. Sorry?
One question: is that something problem specific? Does it have to be specified beforehand? Essentially, how a thought should look like.
Yeah, that's what I understand. So let's say like we want to solve this game of 24, which means that we have like 4 numbers in this case, and we want to find the numerical operations so that this will end up in 24. Then we need to specify like what are each thought about. So each thought is like one equation to reach 24, for example.
Okay.
Yeah, we can have a look on how they build the thoughts, the prompts, because they have the examples in their GitHub repo.
Okay. Thanks.
Yeah. So for the second step, which is called a thought generator, this is a time where we want to generate the intermediate thoughts. So here they propose 2 ways to generate the intermediate thoughts. The first one is to sample. So sample is more suitable on the problems where we have a large search space. Like for example, in the creative writing, we can imagine when we write that a lot of possible words or sentence we can come up with. So the thought space is rich, and that's why it's better to sample. The other way to do it is to propose thoughts. So this suits more the problems where the solution is more constrained. Like for example, in the game 24, like we have like not many different numerical operations. So the thought space is smaller. So it's better to propose instead of sampling it. The third step is to evaluate the state evaluator. So this is the step where the LMMs will think whether the thoughts that generated earlier make sense or not, whether it has possibility to make a good answer or not. So the example is that okay, they have 2 ways on this thought evaluation. Like the first one is to value each state. So in this case, the example is that the LLMs will do look ahead simulations, meaning that they will see like a few steps ahead and see if whether it makes sense with this like combination of letters to make a valid English word. For example, if then the LLMs like generate lots of word that starts with TZX, and like there is no such English word that starts with those letters, so it doesn't make sense, and just forget about these thoughts. The second way to evaluate thoughts here is by voting. This suits more problem with like when the thoughts is reached like the creative writing. So basically the previous step, the LLMs come up with different possible of thoughts, and then in this evaluation step, it will vote which ones makes more sense and makes more coherent passage. The last step, which is the searching algorithm, here they use 2 ways, BFS and DFS. I think it's similar in general on the concept on how we determine when to use breadth first search or depth first search. It depends on the depth of the tree. If we know that the tree depth like is not really deep, then we prefer to use breadth first search. But then the example of like say for when the tree is deep enough, and I think they use DFS for crosswords, if I'm not mistaken. We can have a look. Then it will use DFS, and then at some point when it search in particular branch, when it goes deep and then it realized that if the solution is not there, then it backtracks to the parent and then find a different branch. Yeah.
Sorry, can I ask a question? The choice between BFS and DFS, is it purely for professional efficiency, or what's the reasoning?
I think yes, it's for the efficiency. And also I think they mentioned here, I think efficiency here, yes, in terms of the time, but also we can jump in a bit here that if at some point like where the solution where the solution is placed in the node, then I think if we pick wrong one, it might not be able to find the right solution. That's my understanding. Like if let's say they yeah, that's my understanding here, because for example it already reached the bottom of the tree, but then it's a completely different branch, then it might be impossible to find. But I think the main thing is the
Okay, makes sense.
efficiency. So okay.
So the
Mhm.
sorry, the thing that essentially evaluates how good a thought is also, if I understand correctly, it's also sort of hand coded, right? Or is it an algorithm? Essentially, right? As you go down your chain of thoughts, you evaluate whether it's likely to reach to good results or not, right? As you said, like the example of a letter combination very unlikely being in the English dictionary. But are those also problem specific and sort of hard coded or hand coded, or is it something that is learned, right? Because I think so far it looks more like a fairly normal application of the sub process of, I don't know, reinforcement learning, except the hard part typically is to find these functions that are able to evaluate whether a particular thought is good.
Yeah, that's a good point. They compare with another method that use reinforcement learning, which means that you need to like train another model inside this model, where they hear one of the selling point, they say that you don't need to train another model.
Okay.
So yeah, that's sort of my questions, because I think the thing is that it really also depends on how the human create a prompt. Like I don't think the model learns something, but it will sort of like help. It's like the LLM is not retrained during this process, but it's sort of, but the prompt is sort of like guided.
It's sort of self-guided, right? So
Yeah. That's what I understand.
it almost looks like it's like using an old solution, just applying bigger models in the steps in between.
Yeah.
Well, it still works, right? So that is fine.
Yeah, I think actually with bigger LLMs, like with better LLMs, we might not need this draw thought anymore. Like if the LLM is capable enough to do all of these steps on their own, they don't need humans prompt to help them guide their own thought process.
I think it would be interesting if they can train itself to realize whether a particular thought is a good thought. Maybe there's something about certain problems that generalize across different problems. You know how, I don't know, great scientists can solve problems in many fields because they might be quite good at figuring out what train of thought is a successful is more likely to lead to good results than others, and maybe that is where this eventually becomes stronger than or at least better scalable than any single model.
Yeah, that's true. Um, yeah, so that's the steps in draft thoughts, and this is the 4 things that I think are the selling point. So I think we can discuss whether this is actually a valid selling point or not. Like the first one, they say it's a general ways of solving problems, because then other ways of prompting is actually is just a special case of this tree of thoughts. And then later, I think they claim that they hope this algorithm is a general problem solver. Second point is the modularity, because for those 4 steps, yeah, we can customize within every step, and it should not affect the other steps. So if we want to choose the voting for the evaluation, and then we use DFS for the search algorithm, we can simply change it within each steps. Third one is the adaptability, because they think that it can be used on like different kind of problems. And the convenience, because yeah, I think we discussed a bit earlier, like it doesn't require training another LMs. Okay, so we can have a look at the experiments here. So there are 3 experiments. Wait, where is it? First one, I think we spoke briefly about it. It's called Game of 24. So the problem is that with given input, which is 4 numbers, we want to come up with an equation on how we can reach 24, and each input can only be used once. They compare the experiments with I/O prompting and the chain of thoughts. I think now we can have a look on how the example of the prompts here, so we can see what's the difference. Okay, in the standard prompt, we tell the LM, okay, the instruction is that use these numbers and then find the operations to obtain 24. And this is the thing that's why I said, like, sort of, maybe because this is the prompting in general, it's like we want to guide the LMs to come up with something by giving them examples here. So we give it examples. If this input like this, your answer should be like this, and we give them multiple input outputs example, and this sort of like guides the LMs. The example of the chain of thoughts prompting is that instead of just giving them input and output, we also give the LMs the intermediate thoughts, like, hey, this is your input. And then in order to reach your goal, this is how you do it. Okay, you like sum up 4 and 8, and then etc, 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 and this is your answer. And same with the standard IO prompting, we give these multiple examples to the LMs. For tree of thoughts, I think maybe this one, like the slight disadvantage here is that we need to give more detailed prompting for the LMs. We need to tell them like, hey, okay, because we have those multiple steps in how tree of thoughts work. So we want to give this is the, like for example, when the thoughts generator, sorry, to help the thought generator work, we want to give a propose prompt, like, okay, you have these inputs, then hey, you need to generate your possible thoughts, and this is the example or how you do it, yada 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 yada. And when it comes to the state evaluation, we also want to guide the LMs by saying, hey, now you need to evaluate your thoughts. So this is how you evaluate your thoughts. If you give a number 10 and 14, yes, you can come up with 24 by summing up 10 and 14. Then the answer is yes. The evaluation is yes. And then we give also an example of incorrect thoughts by, like, with two numbers 11 and 12. Hey, these two numbers will not ever make 24, so this is impossible. So this is how we need to state it clearly in the prompting to the LMs to help them evaluate their own thoughts like this. Yeah, I think this also like similar. I'm not sure like why do we need to have two different value prompt, like this first value prompt and this value last step prompt. I don't think it's explained in the paper. But yeah, basically the idea is that we make it deliberate for the LMs by stating it in our prompting that, okay, this is what you need to do and this is the examples how you do it. Yeah, any comments, any thoughts on this prompting?
I actually have one question.
Mm-hmm.
So this is something which I have seen based on my limited usage with LLMs, but what I have seen is most of the times LLMs are non-deterministic, so it's extremely difficult to force them to generate any structured information. Does this paper talks about if they face any issues? For example, generating these equations may not always be, you may not always get the same or on an expected result over here. So do they talk about how to counter that?
I think what they mention related to it here is that they do it like multiple times and calculate the average performance, or like sample multiple times, something like that. But I don't think they mention about it explicitly on how to handle that. So
Can you reduce the temperature? But set temperature 0 with GPT-4 and then always get the same result?
They mention they perform the experiments with the sampling temperature of 0.7, but I don't think they vary this temperature as ablation studies. I personally never play around with this prompting and sampling temperature. What do you think about this changing sampling temperature, like outside this tree of thoughts prompting?
Oh, sorry, was it for me?
Yeah, I mean, yeah.
It might reduce the performance, so you might get worse results, but you will get the same result every time. So that's the trade-off. Right? If you want to fix the results, you might want to do that, but it may not give the best results.
But wouldn't then your thoughts become linear, as in your tree becomes just one branch?
Oh yeah, true that there is no tree. That's the problem here.
I see.
So then, what's the problem with the variance in the responses? Then it's good, right? We want the variance and then create trees, no? Or is the tree different every time? Is it the problem?
Yeah, I mean, for me, it's like maybe the result that is generated may not even be valid. So the first thing is the validity of the response itself. So because of the high temperature value, sometimes you might get an unexpected output, and that's something which you cannot even process for building up the trees. But that's just one of the things which I have observed. I haven't tried this particular paper, to be honest.
Yeah, actually, this is a very good question. How does the output of a prompt get forced into the shape of a thought? Is it like some parsing of some sort, or?
You do the prompt with the prompt, right? You can with the examples you give, you can also request what sort of output you want.
Also, you can tell it, please give me the numbers in that order, and yeah.
Yeah, exactly. And then you give examples, right?
Okay.
Before you ask questions.
Yeah.
Okay. So you don't do any processing on those really anymore.
No, it's
No,
like
yeah.
if you say give me JSON, it will just give you a valid JSON. Or if you describe the format, it will give you that format.
A question. Here you have to actually, when you're restricting your output, you have to restrict it to just generate one step, right? Because in principle, it could give you an arbitrary length or arbitrary complex things. So I'm sort of curious, how do they make sure that it generates a step of the right size? They talked about making, the plan, making the thing not small enough, not too small and not too big. Like if it's too small, then it's hard to evaluate. And if it's too big, I guess then you're not breaking down the problem enough. So I'm very curious, how do they control this output so that it's of the right complexity, like the step in the plan?
I think that's a really good question. I don't know. I don't think they explain here. Is it like, well, to me, is it like trial and error at some point?
I mean, I guess for this particular problem, it's sort of natural to have a step size of 1, right? But you're absolutely right that this is for generic problems that might not be as easily, or figured out what is correct.
Yeah, well, when they say step size of 1, what is 1, right? You have to tell the system somehow that, I don't know what you would tell it. Think about, would the prompt be something like, think about dividing the problem into, I don't know, 5 steps, and just give me the first step, right? Because I'm pretty sure you don't want to ask it to give it all the steps.
So here I would have thought more like propose one operation and where it is applied, and then we take it from there. I would have thought that would probably be the smallest unit of thought in this problem.
So you just tell it, like, give me your first step. What's your first step in the plan?
Yeah, and then that's how I understood it, and then evaluate whether that leads to anything reasonable. I don't know.
Yeah.
But for language problems, that is of course much different, right?
Can this not be controlled by setting the output token limit so that you only get a single or some fixed number of tokens, assuming it will only generate a single output?
I think it depends on how we give input output example. No, that's my understanding on it. Like the way how we give this will sort of like the elements will mimic on how we give this input and answer.
And can the yeah, does the evaluation function learn just on the examples, or I could imagine later on one could give it arbitrary examples of problems and see whether and then train on successful solutions on improving the thought evaluation, right?
Yeah, now I start to wonder with that question, because for example, Game 24 is a very constrained problem, but like for text, here is just the prompt is like, for example, this one, the fourth prompt. The prompt is just analyze each choice and then pick the best choice. Compare prompt is that, like, okay, you have this multiple sentence and I say like compare the coherency. So I don't think those kind of like tokens are controlled here.
Do they give, so here you show the chain of thought prompt, or what about the tree of thought prompt? Do they give it?
For my son is this one, the fourth compare and score. So
But
here,
where do
like,
they want? Because they want to ask about the next step, I suppose, right? Because like these are the different algorithms they benchmark. I think chain of thought is the older algorithm. I'm curious about the vote prompt. That's for evaluation. Yeah, but where's the actual like plan generation prompt?
yeah, they don't seem to put here. I think you're right. Like, I'm thinking whether it's like combination of this standard prompt, like the general prompt to write a passage, and then they put this prompts in the intermediate step instead of putting one standard prompt, because they don't seem to have any other prompts here.
Maybe if we look at crosswords, would that help?
Yeah, let's see. Okay, standard prompt here. Solve, this is input output, okay. The chain of thoughts prompt, okay, solve, that's general prompt, and then inputs, and then they put the intermediate thoughts, and then give the outputs. And then for tree of thoughts, okay, propose prompt. Let's play a crossword, and then we explain. Okay, each word should have actually 5 letters, and then we ask the LMs to list all the possible answers. I think crosswords and the game 24 is similar, no? Like when we first propose the prompt, we tell them this is the problem status and give your possible answers, and then the value prompt is to evaluate. To me, the more ambiguous one is the text. What do you think? I still don't really get the text one though. Like here in the value prompt, they ask them to evaluate whether this letters combination makes sense or not. But for text, like how would we give example of coherent passage or not? Yeah, they are missing that bit. So anyone has any more ideas on how for this text prompting works without clear examples, unlike the crosswords and the game 24?
I think this is not a peer-reviewed paper, and based on the timeline, it was probably submitted to New Lips, and we'll probably see reviewer comments asking the same questions when they publicize it in open review. Just keep an eye on open review. I think it will get some answers there, but not yet.
Okay, hopefully. Yeah, but I think we cover the other examples already by looking at the prompts. They the benchmarking method is pretty similar. They compare with the IO prompt and the chain of thoughts, and then they, like for the IO and chain of thoughts, they will generate multiple samples, and they will see from those multiple samples, input outputs, they will see the average. Okay, and then on the results, they, for example, for this game 24, they claim that Tree of Thoughts has a success rate of 45% with one layer. So yeah, one P here, I guess, is the number of layers in the tree. Well, the previous IO, a chain of thoughts, and then some chain of thoughts is like maximum. It only achieves 9%. So that's what they claim. And okay, what else haven't we covered? Okay, let's just look into this creative writing examples on how the internal thoughts might look like. So for example, the input is that the question is we want to come up with a passage, and then every paragraph needs to end with this sentences, and then the draft thoughts will have intermediate thoughts. Okay, we sample the first intermediate thoughts. This is the first plan, and then we sample another one. Remember here we use the sampling way of thoughts generator, so we can come up with different passages, and then in the evaluation it votes which one is the most coherent. And yeah, here they mention they show how it compares with IO prompt and chain of thoughts, which is again it's a lot better with 70. Oh no, not this one. This is the coherency score. Yeah, but I don't think we need to dig deeper into the numbers. But basically, the idea they claim is much better. And similar with the crosswords. Here the difference that in the setup they use JFS. I think we also touched a bit about it. And then the tree of thoughts has at most 10 intermediate steps. So then for each thought generation, it will see whether the combination makes sense or not. Good combination of the letter makes sense or not. And then during the evaluation, it will assign the confidence level for each intermediate words. Yeah, here one thing for this crossword problem, they mentioned that sometimes even though the crosswords is actually solved, but the state evaluators still think, oh, some words are impossible, and they say it might be the limitation of the LMs in terms of their corpus. So maybe those are the words that are not in, like the LMs doesn't know about those words. That's why it's still thinking that it's impossible. Well, actually, it's a valid word, and the crossword is solved. And then the tree of thoughts keep trying to search, keep traversing in the tree to find, but actually it's not necessary because it's actually solved. Yeah, but I guess again this I think as we mentioned, this will be alleviated with a better LM, so maybe the whole thing is not necessary with the whole LMs, with better LMs, I mean. So yeah, and I think this related work is also we already talked the idea of how human brains think and how LLMs are inspired by that. And here they mention the limitations and what's the future directions. Like, yeah, as you say, like it might not be necessary actually if the LLMs is good enough. Or if for now it can be very costly. And the downside is that because this one is using this off-the-shelf LM, so it's we don't retrain the LMs. So maybe if the LMs is trained on more specific tasks, then it can enhance the performance. Another thing is that, well, because the task can, well, I think about potential danger on environments in humans. I think this is a general problem on LMs in general, so I don't think it's something particular on this method. And yeah, one thing they put as advantage here because we can understand how the LMs thinks in the intermediate steps, then it might improve the interpretability to yeah, it might improve the interpretability because we know how step by step the LMs think. So I think that's all. Anything else? Any other comments? Any other questions?
Yeah, I mean, I think it's very interesting work. One thing I'm interested in is they don't seem to evaluate very much on how good this tree search is, right? I don't know if did they ever compare like the DFS with the BFS, or how important was it that the language model was accurate at evaluating its progress in terms of reducing the size of the tree?
No, yeah, I don't think they do evaluation studies on that. I think they pick directly based on their assumption on how the tree will look like. Like, for example, okay, they think that for game 24, it will not have a really deep tree, so they pick BFS straight away, but they don't compare how it will perform if they use DFS or they compare the breadth, like the number of B, but not comparing the searching algorithm.
Because you would want to show, right? I think what would be interesting to see is like if you change like the search algorithm and the evaluation accuracy, how what effect does it have? Is it what's actually making this succeed compared to the previous algorithms? Is it I'm very curious.
I think here, if we like really want to do like the ablation studies, it would be a lot, because then every step will have different options. Like we might want to compare whether it's better to do the propose or the how do you call it, like the sample one, because then how would we know that for example, the thought space is rich enough, so it's better to do sample versus propose. So yeah, I agree that it would be interesting to compare. I think it's like it will be a lot of ablation studies on that.
We probably could see this. Actually, could we see this as a version of exploitation versus exploration?
Yeah,
Do you
yeah.
go deep or do you check more cases, right? And then there is probably an optimal coefficient to randomly go there or here. So you can probably come up with a mixed version of the two searches. So then it's maybe the next paper.
Maybe the next paper is the graph of thoughts. And how do you compare with this? Okay, if that's all, then I can stop sharing.
Any other comments? Should we do graph of thoughts next week? I guess no comments. So I'll stop sharing. Stop recording.